Hello there everyone, my name is Crazy Caleb and welcome to Bitwise Oblivion. So this is the way the module looks and this is what we're going to be dealing with here. So this is actually a boss module. And what's going to be happening here is that we're going to be dealing with a series of different logical gates based off of the name Bitwise. So what we need to figure out is we need to figure out what we're looking at here. So what's going to be happening is that each time a module is solved, in this case I'm going to be using Note. Also there is a different version for normal play and Twitch plays. But I'm going to be using the normal version for this time around, and I will try and see if I can cover the difference between Twitch plays and Discord and normal play. But in this case, we're going to be using normal play for this example. So until every non-ignore module is solved, when a stage advance condition is met, the module will show a 2x2 grid that has some cells filled and two green circles, one next to a row and another above or below a column. The red number on the top left corner, which will show which stage the module is currently on. And for example, if we were to start this off, let's hit Tool Mods. And as you can see here, this is exactly what we're given here. So we're given a table, which is essentially what's represented by the 2x2 grid, and these green circles represent the true operands and filled cells and the filled cells represent the true results. So in this case, what we're looking at here is we're looking at a logic gate, but it's being presented in a bit of a different way, in this case the 2x2 grid. We're going to be working with a series of different logic gates, in this case AND, OR, XOR, NAND, NOR, and XOR. I would advise you to have some sort of logical background. In this case, I would advise you to click off this tutorial if you do not have any sort of logical background. This is not a module that you want to get into first as your first logical module. So what we're going to be looking at here is, first things first, we need to actually figure out what the logical operator is. And in this case, one of the things that we can realize here is that if we're looking at the true and the false conditions, you can see that in each column and each row, each of them only has one true condition. These black squares represent the true spaces. So in this case, this gives us an idea that we're looking at an XOR. Exactly one operand is true per column and per row. So in this case, if both were true, that returns as false. If both were false, that returns as false. But if exactly one is true, then it returns as true. So in this case, this is going to be our operator that we're looking at here. Now, we're going to note down XOR for this case, and what we're going to also note down is we're going to note down a specific thing that we need to note down. For each stage, we're going to note down which operator in the grid shows, which we just did, and the two strings given by the condition that advanced the stage, which is what we're going to be looking at in just a minute here. So the stage advance conditions is what we're going to be looking at here. This is going to be referring to normal play, because this is what I'm looking at here. Normal play, I'm simply not using Twitch commands to solve the module here, and the way that normal play works is a non-ignored module is solved. The two strings are the name of the solved module that you recently just solved, and a random string displayed under the grid. Now, one thing that's important to note down is you only need the length of the string below based off of the amount that is in the actual name of the mod here. So it is going to be tool mods. So tool mods is what I solved here. It is indeed plural, and this is a series of 8 different characters. So we only need the first 8 characters. So we've got Bravo, 6, Golf, 9, Kilo, X-Ray, Juliet, Mike. And one important thing to note down here is that when we get into later parts of the module, all of these characters are capitalized. And for the specific characters of the modules that you solve, make sure you have correct spelling and correct capitalization of it too. So in this case, the first letter would be capitalized, the rest of them would be not capitalized, and it's very important to note that down. So let's continue on and let's see what else we can do here. Now for Twitch plays and Discords, in addition to the module solved, changing the notes by #notes or notes append will also advance the stage. The two strings are the full text on the note after the change, and the name of the user who changed it, Caesar shifted each letter in the English alphabet shifts around in a positive direction. Shut up, software. Exit here. I don't care. Each letter in the English alphabet shifts around in the positive direction, wrapping around by plus hashtag, where hashtag is the index of the note that was changed. Plus 1 plus. If there are any other boss or semi-boss modules, excluding other Bitwise Oblivion modules on the bottom, instead of every solved module, every queued command will advance to the next stage. The two strings are, if the prefix is command of the queue command is an existing module ID, then the name of the module it points to. The name of the module points to, otherwise the prefix itself without the exclamation mark. For example, #bombdate gives bomb, and #10submit1 gives the name of the module with the ID of 10, if there is such a module, otherwise 10. In the case of a named queue, the name of the command was queued under, otherwise the name of the person who queued it. So as you can see, Twitch plays is a lot more complicated just from even reading that. It obviously makes the two strings a lot harder to get, but it essentially replaces the idea of the fact that you need to get the actual string from below, which is kind of unfortunate. I think that the way that you get the command in normal play is perfectly fine. I think this is completely overcomplicating the actual thing of it, and I'm not really a fan of this how this works essentially. But it's not too hard to process. It just takes a little bit of reading to do. Overall, not the greatest fan of that. But just bear that in mind. Twitch plays is different from how we do it in normal play. This is how I'm covering the normal play example here. So if someone else wants to do a Twitch plays example, by all means, be my guest. Because it obviously is a whole separate mod of itself when it's done on Twitch plays. But let's get back into what we're looking at here. So we've determined for each stage, note down which operation the grid shows, which in this case was XOR for this first one, and the two strings given by the condition that advance the stage. Note that we do not have to note down the entire thing because obviously the length of the mod is significantly less than what the string actually is here. So when the module is ready to be solved, a keypad and a green number in the bottom left corner will show up on the module, and the stage counter will reset to 1. The stage counter, as you can see, is in the top left right now. And for each stage, take the nth character of both strings, where n being the green number is shown for the stage. So let's solve the rest of our modules here. And one important thing that we need to note down here is we need to also remember that specifically spaces are important in this module, and they count as actual characters. Because what we need to do is we need to calculate the binary values of these characters given by their UTF-8 values, which can be calculated below here by entering in a specific character. And if you enter in a character of space, for example, it actually returns as a value. It's very important, and it doesn't mention this in the manual. Hopefully by the time this gets uploaded, it will indeed have a include spaces by at the end of the string, at the end of strings rather. But for now, for the sake of this tutorial, I'm simply noting down the fact that this does indeed include spaces in it because this actually is characters. And it's also very important to note down that the capitalization of this is important as well. For example, with Tango, lowercase Tango gives you 116, but capital Tango gives you 84. That's why it's important to have punctuation be correct, instead of doing something like all caps, with what I do. So that's what we're going to be looking at here. So let's get the rest of these modules solved, and let's identify each of their logical operators. So let's do letter keys, for example. So we have divisible by 6. Divisible by 3, it is indeed divisible by 3, but the battery case does not apply. CE or 3 in the serial number. No, it's going to be alpha. Okay, that's good. So now we're taking a look here. And one thing that we can realize here is that if it's true, it's going to return as true. And if it's false, it'll return as true. So this is likely a case of an XNOR. Either both or neither of the operands are true. So in this case, XNOR is going to be our operator here. We just solved letter keys, which in this case is spelled out like this. And now we need this amount of characters. We need 1, 2, 3, 4, 5, 6, 7, including the space, 8, 9, 10, 11. So we have 11 that we need to include. Now, also here's another thing to point out. These are Oscars. Zeros are much thinner. It's a bit weird how it does this, but that's going to be the way that you're going to determine it. Oscars are a bit wider. Zeros are much thinner. And they're kind of clear to see, but you have to make sure that you pay attention to it. So we've got Oscar, Mike, Uniform, Lima, Tango. And by the way, every single letter is always going to be in all caps on this display. So that's one thing to point out. So 0, X-ray, 0, Alpha, Yankee, Foxtrot. I think this should be enough. We needed 11, right? Selecting 11. Selecting 11. There we go. Okay. Let's go to the next stage. And as you can see, this boss module might take a while to explain, and I'm sorry about this. Let's do the simpleton. Victory! We got the uniform, nice. So we get now here. A false true is, if it's a false true, it's true. If it's a true false, it's a true. This is an XOR case again, and we just solved the simpleton. We needed quite a few characters here. So we've got Hotel Victor Romeo, 5 Juliet Sierra India Uniform Charlie Romeo. Should be enough at this point, I think. Maybe a little bit more. 5 Tango Tango Uniform X-ray. So highlighting, we've got 14. Highlighting, we have 13. Just get rid of 1, and there we go. Next up, let's take care of Hitman. Jimmy Chen. Okay. Ooh, okay. So we have here, in this case, is a false. False is going to be returning as false, and the rest will be returning as true. And in this case, this is going to be representing an or. At least one operand is true. And in this case, this applies to every single case here. This row is true. This column is true. Therefore, that's going to be an or. So we have or for this one. And this we just solved Hitman. So that's going to be 6 characters, Hitman. And we have a 7 Foxtrot 0 Kilo Zulu Foxtrot. 6 characters. That's all we need. And finally, let's do Minesweeper. So second digit is a 4. Voiperb 3, 5. Okay, 1, 2, 3, 4, 5. Let's do this real quick here. What did I miss here? This? Yes. There we go. Nice. And now we enter into a solve state here. In this case, it looks like a keypad. We've got 0 through 9. We've got a clear and a submit. And now here's where these numbers come into place here. So we have a 4 in the bottom left, which is essentially going to be representing the position of the nth character of both strings, with n being the green number shown for the bottom stage. So in this case, 4. So we need to take the 4th character of each of them, which in this case is corresponding to a lowercase lima and a 9. Now, with this in mind, we're going to calculate the binary value of these characters given by their UTF-8 values, which in this case, we will get a decimal value, and I've got the base converter up here to help me. So we have, so we're going to do from base 10 to base 2, because this is going to be in decimal form, and we need to get 2 binary. So now, let's plug in these guys. So we've got lowercase lima is going to be 108, so 108 is going to give me this. We're going to get u. And for the 9 is going to give me a what? 57. 57 is going to give me this sequence. Now, one of the things that you might immediately realize here is that these strings are not the exact same length. So, what exactly do we do in this case? Make sure both binary numbers have the same amount of bits. Add zeros to the beginning of the shorter one until its length matches the longer one. So in this case, we're just simply going to add a 0 to the beginning here. Boop, and there we go. Now, what we're going to do is we're going to apply the stage's logical operation to each of their bits. In this case, 0 represents false and 1 represents true, and input the result in its decimal form using the keypad on the module. It's very simple to do. So now with XOR, we want exactly one of them to be true. Exactly one operand is true. So in this case, this first bit of 1 and 0 is going to return as 1. 1 and 1 is going to return as 0. 1 and 0 is going to return as 1. 1 and 1 is going to return as 0. 1. 0, 1. And now we're going to convert this to decimal. So we're going to convert this from base 2 to base 10 in this case. I'm too lazy to go over binary in this instance. So now we get 85 as our total. We're going to submit 85. And that is the first stage done. And just like that, it changes to stage 2. And now we get a new number. It will never be the exact same number for each of these guys. It will be a completely random number. And as you can see, this takes a long time with a lot of modules because you have to calculate each individual one. You do not know which character you're going to get immediately. And that's what makes this a little bit weird. So let's take a look at this next example here. So now we've got a character of 1. So it's going to be a Lima and a capital Lima and a capital Oscar. So capital Lima. That's going to return as indeed 76. So from base 10 to base 2. 76 convert. Then we have a capital Oscar. That's going to return as 79. That's not too far off. Convert. It is the same amount of characters in each bit. That's good to go. Now, we're going to be doing this with XNOR. Now, both operators must be the exact same. Either both or neither of the operands are true. So there must be the exact same, in this case, for it to return 1. So in this case, 1, 1, 1, 1, 1, 0, 0. And that's going to be it right there. So now let's convert you back to base 10. Okay, convert is going to be a total of 124. There we go. Now we're taking a look at the first character. Unfortunately, we did not get the case of any spaces, but trust me when I say this, a space is a character. It's very clear when you see that it goes from NA to a 32 when you hit space, so that's just very important to note down. If it happened to be, for example, 4, or for example, 5, it would be 1, 2, 3, 4, 5 to the capital Sierra in that instance. Very important to note that down. So, let's continue on though. It's the first character, capital Tango, capital Hotel. Let's see what we got. So capital Tango is an 84. Let's go from base 10 to base 2 again. 84. Vert is going to be that. And the Capital Hotel is going to be a 72. And that's going to give us this. Okay. Now we're going to be converting this into XOR. So XOR needs to be exactly one operand is true. That's going to be 0, 0, 1, 1, 1, 0, 0. I might actually be able to do this one in my head. 1, 2, 4, 8, 16. 16 should be 28, I want to say. I'm going to double check that, but it should be 28. Just from my basic binary knowledge that I have here. Should be 28? Indeed it is. So now let's submit that into the module here. And let's get our last one. In this case, 5. 1, 2, 3, 4, 5 gives us a lowercase alpha. Lowercase alpha is going to be what? 97. Base 10 to base 2. 97 is going to be a 11000001. And then we have, for the fifth character, we've got a capital Zulu. Capital Zulu is going to be right here, 90. Okay. That's going to return this. And this is an OR. As long as there is at least one 1 in each position, we're good to go. So 1, 1, 1, 1, 0, 1, 1. Bringing this back into binary. I'm converting this back from binary into decimal. And this will be the final stage, be it 1, 2, 3. This is our last stage that we had here. When we hit submit, just like that, is a solved module. Since this module takes a long time, this is going to be the only example that I cover. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.